question 10. A backyard has a perimeter of 144 meters. If the backyard is a square, what are the dimensions? So a square has four equal sides. And you can represent this as an equation as 144 equals four sides, so 4s. And so I'm going to plug that 144 in. And how do I get what a single s is going to equal to? Well, if I divide the number of sides, of four sides, so the 144 by 4, I will get 36. So that means each side is going to be 36, and therefore let S represent the side length of this square, and therefore this dimension is going to be a 36 meter by 36 meter. Meanwhile, for part B, so for question 1b, so for question 10a, we noticed that a square will maximize the area at 36 meters by 36 meters. For 10b, this case we have a rectangle and the length is 3 times the width. So in order to set that up, it's helpful to write some let statements. So for example, well, let x represent the width and let 3x represent the length. So generally the length is represented by the longer side. And so I have one side that is 3x and the other side that is equal to x. And so I'm coming up with my perimeter formula because we're given the perimeter of 144. And notice that when I'm writing it down, I'm not just adding these two, but I am doing 2 times this value, so 2 of these x's and 2 of these 3 x's. So I have a 2 at the front to make up the fact that there are 4 sides in total. With that in mind, I'm going to simplify it, and so I will get 144, because that's the perimeter value that is subbed in, is equal to 2x plus 6x. On the right side, it is going to simplify to 8x equals 144. How do I get x by itself? Well, right now, x is being multiplied to 8. The opposite of multiplying is dividing. So I'm going to divide both sides by 8. And so I will get x equals 18. And am I done? No, because that represents my width. I need to quickly find my length as well. So when I do that, I will get length 54. So you write a therefore statement saying, therefore, 18 meters by 54 meters will make this rectangular fencing area. Okay, there you go. And question C. Question C, this time, so we had a square, we had a rectangle, now we have a triangle. We have a triangle where we have the slant height of x, and we have the base of x minus 2 divided by 3. So as the first part, I'm going to start by writing down the perimeter setup. Well, the perimeter is going to be made up of everything on the outside being added, because perimeter is simply how much space, what is the dimensions around the outside. So once I have that, there are a couple of ways to figure this out algebraically. One way is that you might multiply each term by a potential LCD. So that's just one way. So right now, all of these other values have an LCD of 1. And so I'm noticing that the lowest common denominator between 1 and 3 is 3. So I'm going to multiply every single term that appears by 3. So that's one strategy you can use. So that's what I get. And I notice that these will cancel out, which is why we did it. And so we get 432 equals 3x plus x minus 2. The like terms are going to add up. And you get 432 equals 7x minus 2. I want to get x by itself by using BEDMAS backwards. So you've seen this a lot by solving the equations. So I want to get my x by itself, and I'm going to do BEDMAS backwards, and I'm going to add 2 to both sides. And so I will get 432 plus 2 equals 7x, which will be 434 equals 7x. I want to divide both sides by 7 so I can get x by itself. So 62 equals x, or x is equals to 62. So that is my slant height. So next, I'm not done because I need to figure out what my base is. So I'm going to plug in 62 for x. And so I will do that right now, and I will get 60 divided by 3. That simplifies to 20 meters. So basically at this point, you can conclude that the dimensions that make up this triangular fence area is by 62 meters by 62 meters by 20 meters, okay? Meanwhile, I do this optional step 3, and this optional step 3 is to find the height. And the reason is because for the following question. So not really for question C, but for question D. So the reason is I'm trying to find this height for now because I'm asked the area in the next question, and I kind of want to have it all on the same page. So I would have actually had my therefore statement here, so I'm going to modify a little bit, and then I would put that as an optional step for later. Anyway, so we notice that if you look at this right angle triangle and just look at this part, we notice that the hypotenuse of that is 62 because that was the x. And we want to figure out what the height is. So let's go ahead. And so I plugged in the 62 for the hypotenuse. I don't know what the height is, but why do you think I put a 10 there? Well, I put a 10 there because if this whole thing is 20, that means halfway is going to be 10. And so this is going to be 10. And from there, we're going to do Pythagorean theorem, and we're going to try to get the b by itself. So I have 10 squared, which is equal to 100. And so what I'm doing is 62 squared is equal to 3,844. 10 squared is equal to 100. I'm going to move that to the other side by subtracting by 100. So 3,844 minus 100 will be 3,744. Well, once I get that, I will need to square root both sides so I can get what b is equal to. And b is equal to 61.19 meters. And part D, it is asking which of the 3 backyard designs has the greatest area, which has the least. So there are 3 kind of shapes that we went over. We went through a square, a rectangle, a triangle. So let's take a look. So you would go back to the dimensions and complete and start calculating the area. So I get, well, square, it's 36 times 36, so you get 1,296 meters squared. Well, what about the rectangle? Well, the rectangle is going to be 54 times 18, and we notice that it's 972 meters squared. So slightly less than what we get for the area of a square. Meanwhile, for the triangle, we notice that it's 20 times 61.19 divided by 2, and it has the smallest area. And so what you would conclude is that, well, between all the 3 shapes, although you're dealing with the same perimeter of 144, we're noticing that a square is going to maximize the area. And this is actually going to be always true if you are given the same perimeter situation and you're dealing with different shape. The square will always maximize the area, which is a concept that we will see again. Okay, and so the least, between the 3 shapes, the one with the smallest area is a triangle. All right.